Verification of the principle of conservation of momentum. In this experiment, we focus on the principles of force and momentum. Mass is determined by the amount of matter in a body, a measure of body's inertia or its resistance to its change in its motion. It is a scalar quantity with an SI unit of kilogram. Momentum is a product of mass and velocity. It is a vector quantity with an SI unit of kilogram meter per second. The principle of conservation of momentum states that the total momentum before an interaction equals the total momentum after, provided no resultant force acts on the system. An elastic condition is one in which no kinetic energy is lost. Perfect elastic conditions can occur when objects do not touch each other. In the case of an interaction between two bodies, the initial momentum of the bodies equals the final momentum of the bodies. The principle can be written as follows, where m1u1 is the initial momentum and m2u2 is the initial momentum of the second body. Hence, m1v1 and m2v2 is the momentum of the first and second body after impact. Find the mass of both trolleys. Set up apparatus as presented, attaching one end of the ticket type to the trolley and the other to the ticket timer. Ensure the runway is correctly sloped so the trolleys move at constant velocity where the frictional force is equal and opposite to the gravitational force. When the trolley is pushed, it gains kinetic energy, hence u1 or the initial velocity is obtained and the vector can be seen heading towards trolley number. Employing the conservation of momentum in this scenario, with trolley 1 collides and sticks to trolley 2, trolley 1 imparts some of its momentum onto trolley 2, and the final velocity of the combined body is half the initial velocity, given the mass of the trolleys are approximately equivalent. As mains electricity operates at 50 Hz, the ticket timer produces 50 dots per second. At the starts, the dots are slightly close together because the trolley hasn't moved far after the initial push. Immediately after, the dots are equidistant due to the constant initial velocity. At the point of impact, the dots become close together again as the energy is being transferred. When the dots become equidistant again after the point of impact, indicates the constant final velocity of the combined trolleys. To calculate time taken on the ticker type, we must know that as the timer produces 50 dots in 1 second, it will produce 1 dot in 1/50th of a second, meaning that 10 dots account for 1/5 of a second. As velocity equals distance over time, the distance is measured between the 10 equidistant dots before the point of impact. With this equation, we get the initial velocity to be 0.67 meters per second. For the final velocity of the combined bodies, we measure the distance between the 10 equidistant dots after the point of impact, and the final velocity turns out to be 0.335 meters per second. As we learned, initial momentum of bodies equals the final momentum of bodies after collision, and that as trolley 2 is at rest, its initial velocity is 0 meters per second, and when the bodies combine and stick, their velocity is the same. Therefore, v1 equals to v2. After the calculations, it can be seen that the total momentum before collision equals the total momentum after collision. An alternative experiment to verify the conservation of momentum requires a new door.
3, 2, 1, go!